First of all, we are manipulatives based. We want to see your student walk through our curriculum using manipulatives consistently from our primer all the way through Algebra 1. It's going to take your student from the concrete to the abstract understanding. Research has shown that students retain math concepts better when the same manipulatives are used consistently. And so you're going to see a lot of curriculums use these as a supplement, but we find research shows that if you can use them consistently, it's to bring more clarity for the student. And we do recognize that every student has a learning preference, but they can learn in any style. The most effective approach is to teach involving as many senses as possible. When we teach using more senses, we can communicate more effectively and with more clarity. This is one of the reasons Math UC is so effective for such a broad range of students. And one of the common phrases you're going to hear with Math UC is to build it, to write it, and to say it. So we build it using the blocks, we write it down on paper, and then we say what we're doing. Here are 3 different types of manipulatives. And the most common one you're going to use is our integer block kit. We're going to use them all the way from primer through Algebra 1. That's the one on the left. The only level we will not use them for is our fraction overlay kit when we get to epsilon. Epsilon is our fraction level. And so instead of using the integers, we use something different. We have overlays that we use to teach fractions. Then for the remaining levels, zeta, pre-algebra, and algebra 1, we're going to use our algebra decimal insert kit in combination with our integer block kit. And this will help us understand decimals and percents. It's also going to help us understand polynomials with x, negative x, and x squared. And so those are 3 different types. And once again, we use manipulatives consistently to bring more clarity, where it's not a supplement, it's a main way that we teach. We want to see students master each new concept before moving on to the next concept. Step 1, with every lesson, we have a DVD that corresponds with that lesson. The DVD is really there to help you as a parent see how to teach the lesson with the blocks. And so these lessons are about 5 to 10 minutes long. It's not too long. You're only going to watch it once a week. And after that, you as a parent are going to show them how to do it using the blocks. So that's step 2. So step 1, you watch the video with or without your student. Step 2, you show them how to do it. And step 3, we want them to practice. A lesson is going to contain 3 pages of practice. It's going to contain 3 pages of review and a test. And so we want to do just 1 page of practice a day. I struggled in math, and I did very well when it came to the daily work. When it came to reviewing and testing, I struggled because I didn't understand the process. I could get you the right answer, but because it didn't stick with me, reviewing and testing was a big struggle. And so that's what we look for, is if you can say, this is how I get to the answer and understand that piece, that shows you mastered it. And so it was clear that I didn't master because I didn't understand that piece, and that's why reviewing and testing was such a struggle for me. Why do we teach math? You're going to hear Steve Demme ask you that question, and the reason is to apply it to everyday situations. The goal of Math UC is not only to teach you how to do math, but why you do math and where the formula originated. Conceptual learning develops understanding of how math is used in real-life situations. One of the stories you're going to hear Steve Demme give is one day he went to his classroom and he had 7 students and he ran 14 objects, and he said to them, how many objects do you each get? And they looked at him and said, I don't know, Steve, do we add, subtract, multiply, or divide? They knew 14 divided by 7 was 2, but they didn't know how to apply it to everyday situations. And that's where Math UC really focuses in on. You're going to notice we do not go by grade level, but we go by the Greek alphabet. And we do it for a few reasons. A lot of times, we put 16-year-olds back into our alpha level, which for you as parents can see that's really early on. That's around our 1st grade level. And we don't want students to recognize that that's the level they're in. We want them to be able to focus on where they are academically, not based upon where the education systems they need to be. Steve Demme, once again, referring back to him, he says, you are where you are. And these early levels really set the foundation for being successful later on. And if we don't have that foundation set at that time, later on it's going to become more and more of a struggle. I had a student come to me, and they sit at a homeschool conference. He was with his mom. It was in Oklahoma City. And he said, you know, your curriculum is easy. And I took a step back. I didn't quite know how to react to that. Well, he said that his mom said that I was amazed at what he learned through the Delta level. And because we didn't give him more than what he needed to know, and he mastered every step, the curriculum was easy. If it's hard, it means that they're not grasping it. There's maybe a learning gap, or maybe we're giving them information and tasking them to answer a question that they're not ready to answer because they haven't received all the information. And so it's our goal to make sure that they're taking the proper steps and mastering each thing so that the curriculum is easy. One of the common questions I get is, are you only teaching, for instance, in alpha, single-digit addition, subtraction, or in beta, multiple-digit addition, subtraction? That is our main topic that we're going to teach everything a normal math curriculum is going to teach. We're going to teach it when it makes sense to teach it. So for instance, perimeter. When we are not going to teach perimeter until they can learn how to add 3 or 4 numbers together. Area, we're not going to get into area until we learn how to multiply. And so we're going to put them in the right spots when it makes sense to teach it. But everything will be taught as a normal math curriculum teaches. And so I'm going to introduce you to our manipulatives here. You're going to see that each one of these is going to represent a different number. You can see our 2, this is our 2 block, it's orange. Our purple block is 6. And so what I've done with my 5-year-olds, the first thing we did is we went through these and we talked about how each one of these represents a number. And we gave them nicknames. And so for instance, he's the biggest fan of Thomas the Train. And Thomas, if you know him, he is blue. And so this is Thomas Blue 10. In math, you see, this one is the number 8. It looks like a Hershey's bar, and so we call this Chocolate. Our 3 block here is pink, so this is kind of an easy one, but the 3 pink little pigs. So you kind of have nicknames there so they can associate the number with the color. And the first thing that we're going to teach here is counting. And we're going to use the decimal system when we talk about counting. When I grew up, we talked about counting from 1 to 10. Well, we teach counting from 0 to 9, and then we start over. And what that means is 0 to 9 are counting numbers. They tell me how many, but they don't tell me what kind. And what I mean by that is if I said I have 2 in one hand and 4 in the other, what's bigger? It's the 4. But it could be 2 quarters and 4 pennies. So now the 2 is bigger. So it really depends on the kind that is associated with it. And so when we talk about that, we look at this here called Decimal Street. And this comes in with all of your manipulatives. And Decimal Street, we have 3 different houses. We have our units house, our tens house, and our hundreds castle. And this is something that I didn't grow up with either. We had the ones, the tens, and the hundreds. Well, we call this the units house because ones are counting numbers. Units are a kind. And so we have our units, tens, and hundreds. And so within our house, we can have up to 9 living in each house. We can have less than 9, but never more than 9. So we talk about having 9 chairs, we have 9 beds, we have 9 toothbrushes, and if a 10th knocks on the door and says, I need a place to live, well, we ran out of room and we have to upgrade to a bigger house. And so that's where our tens house comes into play. And we call this our T house, TY, because I'll say 20, 30, 40. I'm really saying 2 tens, 3 tens, 4 tens. And the same rules apply here. We can have up to 9 living here. Finally, you can't see everything on here, but this is a big castle. And this is where our hundreds live. So as we build numbers, the same rules are going to apply. We can have 9 hundreds in the castle. We can build numbers, say 123. Now, occasionally, everybody might leave the house. They might go on vacation. They might go to a homeschool co-op. Whatever the case is, everybody's gone. And so we need someone to watch the house while we're away. And so we need someone to water the garden, maybe not this time of year, mow the grass, maybe scoop the snow is more like it, get the mail, those type of things while we're away. And that's where our hero, Mr. Zero, comes into play. So even though everybody's out of the house, we still need someone living here. So now we have 103, okay? And so that's kind of how we talk about place value and building numbers. From there, we're going to move into single-digit addition and subtraction. When I first learned to add, my mom got out the pennies for me, right? And she got a problem here. She built 4 plus 2. And I was so bright that I was able to do this problem and go 1, 2, 3, 4, 5, 6. And I got the right answer, but I'm still counting, right? And so what we really want to do is we want to wean from the green, is what Steve will say. We're going to move away from these unit cubes to these other blocks here. So we have our 4 block and our 2 block. And as I mentioned, one of the main focuses of math you see is that we are understanding. And so we're going to talk about what does plus and equals really mean. To a 5-year-old or 6-year-old, this might be a tough concept. And so we talk about plus really means to combine something. And we combine something, we push those things together. Equals really means the same as. So what number is the same as 4 combined with 2? We don't want them to count, but we want them to try a few things. And eventually, they're going to choose the 6 block. And they're going to know that's the right answer because it creates an equal sign. You can see there, it creates an equal sign. And so they can start to picture in their mind, yellow 4 plus orange 2 is the purple 6. And so they can build it, they're writing it, they're saying it all at the same time. Once we get our math facts memorized, and that is our goal, is we want to have all of those facts memorized from 0 plus 0 up to 9 plus 9, we're going to move into solving for the unknown. And so we might have a problem that looks like this. And we're going to do 3 things here. First thing we're going to do, this is going to reiterate our addition facts. Second thing it's going to do, it's going to teach algebra concretely. Even at this level, we want to start teaching algebra concretely so that when they get to algebra, it's not scary because they've seen a lot of these things before. And a lot of times we get scared of algebra because of the name of algebra. And so we want to put that behind them where they start to see these things before they get to that level. And the final thing it's going to do, it's going to start getting them ready for a single digit subtraction. And so what we're going to start to do is after they see this blank, we're going to take that out of there and we're going to start to put in letters. So they can start to see 4 plus n equals 6, or 4 combined with what number is the same as 6. So they can start to see that that equals 2, okay? And then they can type right in here if they'd like to, n equals 2, okay? And then from there, we're going to move into single digit subtraction. So we're going to do 6 take away 2 is the same as what number? 6, we're going in the whole 2, however you want to phrase that. But we want them to understand that we're taking some away. And the way that we do that with subtraction is we flip it over. And if you can see, it's hollow inside, so we can show that we're taking those away. So we have 6 and we're taking 2 away. So we're going to put 2 on top of there to show we're taking those away. And we can see that that's going to leave us with 4 remaining. So 6 take away 2 is the same as 4. Okay. Then after that, we are going to move into multiple digit addition subtraction. So the assumption is now we have all of our addition and subtraction facts memorized, and we're going to do multiple digit addition. So we might have a problem like 18 plus 14. So let's build that problem the way that we see that. So here's our 18. We have our 10 block and our 8 block. And we have 14, our 10 block and our 4 block. So when we add a problem like this, first thing we do is we add to the units column. And one of the phrases you're going to hear a lot in Math UC is to compare and combine, you must be the same kind. And what that essentially means is we have to combine the units together, the tens together, the hundreds together. We can't go units to tens or tens to hundreds. They have to be the same place value. So we're going to add the 8 and the 4. Well, we have a problem. The problem is if we go back to place value, I have too many people living in my house. I only have 9 there. Well, I have 12. So if I remember, 10 have to go to the next house. So if I have my single digits memorized, 8 plus 4 and 10 plus 2 are the same. You can see that there. And so we are going to carry not 1, but we're going to carry 10. So we want students to recognize that that's what we're doing. So now I can add 10 plus 10 plus 10 to get to 32. Okay? Now when we do subtraction, we can have 32 take away 16. Okay. So the first thing we do is we take 6 away from 2. Whoops, we can't do that, can we? That doesn't work. And so let's pretend we're at home making chocolate chip cookies. And occasionally when we do this, we might run out of flour or out of eggs. And in this case, we're not going to go to the store. We're going to see if our neighbor has any. So our neighbor's going to help us out. They can come to our house. They just can't live with us. And so we're going to ask our neighbor to come over and help us with the cookies. So they're going to help us with the eggs. They brought the eggs over. And now I can take 6 away from 12. And that's going to leave me with 6 remaining. So I can substitute that out. And now I take 10 away from 20 to leave me with my answer of 16. So when we think about borrowing, we think about going to our neighbor's house and having them come over to help us with the cookies. And so that's where this visual of the houses really comes in. And this place value is so essential to help understanding these different concepts and the different operations that we're walking through. After we have addition and subtraction down, we're going to move into multiplication. And in multiplication, we focus in on skip counting at first. And skip counting is really there to help build a bridge between addition and multiplication. And when we skip count, we focus in on the final value. So in this case, it's 10, 20, 30. I can also see this as a big rectangle. So in Math U See, we use rectangles to help solve our problems. So here is 10 over, and it is 3 tall. So I know 10 times 3 is the same as 30, okay? So that's how we're going to teach our single-digit multiplication. Now, as we jump up to doing larger problems, we might do 14 times 12. And when I do a problem like this, I always take the top one and build it over, and the bottom one and build it up. So now, 14 times 12. We're going to start with our 100 block because I know this is 10 over and 10 tall. And so 10 times 10 is 100. So I know this is going to be greater than 100, right? So now I have to go 14 over. This is 10 over. So I'm going to add these 10 blocks. Even though these are 10 tall, these are only 1 over. So 11, 12, 13, I need 1 more to get me to 14, okay? Now I have to build it 12 tall. Here's 11 and 12, but I'm not complete yet. So I'm going to use my unit cubes here to fill in my blank. Now I have a full rectangle. I have 10, 11, 12 tall, 11, 12, 13, 14 over. Now, one of the problems I have, if I look at place value, I have units, tens, and hundreds. To compare and combine, you must be the same kind. I can't have units with tens and tens with hundreds. So I'm going to take this down a little bit and shift it over. Now I have my different place values. I have units, tens, and hundreds on their appropriate spot. Okay? And so the first one I'm doing here is 4 over times 2 up. See, 4 times 2 is the first thing we multiply. Well, here's 4 over and 2 up to give me 8. Now I have 2 up, not times 1 over. This is our tens column, so this is times 10. So 2 up times 10 over to give me 28. My top row has to be 28. Now, I was always taught to put a 0 here, but I never quite understood why. Well, my why is, if I remember back to place value, if everybody's out of the house, then our hero, Mr. 0, has to be there. And I don't have any units, so I'm putting a 0 there. Now I take 10 up times 4 over. Here's our 4 over and 10 up to give me 40. And I have 10 up times 10 over to give me 100. And so now I can add. I have 8 plus 0 is 8. 20 plus 40 is 60. And then 100 plus 0, 100 is 100. So my answer here is 168. Okay? And so we use that to help them understand, how does multiple digit multiplication work? And if I get to a problem like this, I will no longer use the blocks. It's going to be complicate things too much. But what we want them to see is no matter how big the problem gets, the process stays the same. Okay, and so we're going to use those for a while to help them understand it. But as we get bigger and bigger with problems, because they built that understanding through using the blocks, through saying it, through writing it, they automatically have this where they can do a large problem, a larger problem, just using pencil and paper. From here, we're going to move into division. This is the last thing I'm going to cover before questions. We might have a problem like this. And the way we solve division problems is very similar to how we did multiplication problems. We can look at this as half of a rectangle, can't we? So we have one side of the rectangle is 4, and we have to see how many times we have to count by 4 to get to 20. So this side is 4. Now we can skip count to 8, 12, 16, and 20. So this side is 5. So answer is 5. And what we see a lot of times, if students struggle with division, it typically will mean that they have really struggled with multiplication. They may not have their multiplication facts memorized, and when that happens, they get lost into some of these big problems because they're not sure which number to bring down and which number has to be divided into what or multiplied by what to get to that answer. And so the reason we don't do, for instance, when we do multiple digit multiplication, we have to know our addition well because part of multiple digit multiplication is addition. To do division well, we have to know subtraction as well as multiplication. And so it all kind of slowly takes the proper steps to get to this point. And then we get all 4 of these operations down, we're going to do fractions. We're going to learn how to add, subtract, multiply, and divide fractions. So you can see how we teach sequentially and how these blocks build upon itself to help the students understand each concept.